Um, Hello, all. Welcome to the next part, which is the fifth part in the introduction to AI and its role in chemistry. This is part of the AI in chemistry videos. So, in the previous video or in the previous part, we have seen about how do we use Google Colab. We got ourselves used to Google Colabs. We had a quick revision of some of the basic concepts of Python, like the print statement, conditional statement, looping statements, functions, dictionaries, and lists. And we also looked at working out these examples on Google Colab. Though Google Colab is a great way to learn Python, sometimes using Google Colab might not be the right choice because you might have some sensitive data where you might want to run the Google your Python programs locally. So in such cases, we will use the Python, the local installation of Python. So in this session, we will see how do we install Python locally using a distribution called Miniconda. There is also another distribution called Anaconda, but we will be using a distribution called Miniconda to install Python. So we will see the steps for installing Miniconda in our local PC, and we will also see how do we execute programs from there. So to begin with, why we install Python locally? So one of the reasons for installing Python locally is that we can also work in an offline mode. So when you want to work on Google Colab, you always have to be connected to internet, right? But there might be some projects or cases where you have to work on a very sensitive data which is not even connected to internet, right? In such cases, this might happen, or there are some cases where even Google might be blocked. I mean, I'm just telling you a scenario, or you are having very sensitive data that you cannot put anything on internet, or Google Colab itself might not have certain packages. Again, though you can install the packages, but there are certain version configurations where you will not be able to install the required version of Python or required version of Google Python package. So you might have to deal with that, and there you will not be able to do with Google Colab. So you have to install them locally, or maybe you want to use the Python. See, whenever the Python code is that you write in Google Colab is only for, like, experimentation or learning or knowing. But when you want to build a product, when you want to create a software, then that Python code has to run locally. Yes, you can also create that in Google Colab, download it and run locally. Nothing wrong. But finally, you might have to run your Python code locally on your machine or on a server to make a product out of it. Or maybe you want to, integrate it with something else. For all of them, you need to have your code run on your machine or on your server. That is why installing and running the Python code locally is very, very important. Again, you can configure based upon your development needs. You have full control where you can, install libraries, or maybe you can run different scripts, and you can build applications. And also, because it has the browser limitation is not there, you can actually execute. Because, for example, especially it happens like when you are working on computer vision, that is images and stuff like that. Sometimes Google Colab, I'm not saying all the time, there are some few cases where Google Colab poses certain limitations, and you might have to tweak the code slightly to run it on Google Colab. So this also helps in that way, and it is also slightly faster as compared to the Google notebook when you have a good amount of RAM, right? And to install Python locally, you need to have at least 8 GB RAM machine. That is recommended. Okay, if you have 4 GB RAM, that is also fine, but having a 8 GB RAM is a much better option. If you have an 8 GB RAM, then it will be very helpful for you. So you can run your Python programs locally. So for that, you will have to install something. So Python has various distributions, right? And one such distribution is called as Anaconda. And A miniature version of that is called Miniconda, and we are going to use Miniconda. Again, why Miniconda? Is because when we are using Anaconda, it might come with a lot of, I would not say unnecessary things, but lot of things which is not required at the very initial stage. Okay, that means it comes up with a very lightweight and clean one with no bloatware. I mean, even when you buy phones, you get something called as a bloatware. The bloatware is in your phone itself. It comes with lot of necessary / unnecessary applications which you cannot even uninstall. So, but anyways, here when you install Anaconda, it comes up with so many other things which might be necessary or which might not be necessary. But when you install Miniconda, it comes up with a very clean version and you can start using it. And another advantage is that it does something called as environment management. What is environment management? Now, suppose you are working on 2-3 projects, assume, and project A requires some set of packages and project B requires another set of packages, and these do conflict. So, you cannot have them together. So, the Anaconda or Miniconda gives you something called as virtual environment, where you can create a separate environment where certain set of programs run and another set of programs run in a different environment, so that they don't conflict. Okay. Again, the other important thing is dependency handling. See, one of the important things in Python is packages. So, what are these packages is, suppose let us say you want to load a data file and do a search operation in that, or you want to sort them, or maybe you want to find out what is there in the 5th row, 6th column, or you want to find some data based on some conditions. Doing that with Python alone will be very, very difficult, because you have to read the file, then read line by line and read the line where you have that, and then find the place where in that line that word is there. It becomes very, very difficult. But let us say there is a package called Pandas which is used for handling data files. So, it just by 2-3 lines of code it does it. Basically, packages are an abstraction. Abstraction means all the underlying things are hidden. You will only load the data and do exactly what you want to do. It's a package, right? For example, let us say when in a marriage, right, you have a catering package. So, instead of you giving one activity like stage decoration to one person, hall decoration to one person, then seating arrangement, food, then chat counter, juice counter, all of them, you give it as a package. That guy takes care of everything. Instead of you doing a lot of coding, if you use a package, that package will take care of that. Examples of such packages are Pandas, NumPy, Matplotlib, and there are so many packages, we will see that. So, when we are working on Python, we have to install lot of packages. When you are installing these packages, there might be some conflicts as well as dependencies. So, when you use Miniconda or Anaconda for that matter, it will take care of handling the dependencies or conflicts, all these things it will take care of. And it will also help you to quickly install data science libraries like Pandas, NumPy, Matplotlib. These are all the advantages. Now that we have known what is Miniconda and what is local installation, let us do that local installation on my laptop. I already had Miniconda installed on my machine. I have uninstalled it. I'm going to do a fresh installation, and I'm going to do with the assumption that you will be using a Windows machine. For Linux or for Mac, it will be slightly different. You might, once you follow this, you might be able to do it for Linux and Mac as well, or you can just refer to the screen that I am going to show now. So, what you will do is you will go to Google, type install Miniconda, then it will come up with a website. Just go to that website. So, here you can look out for Windows installation. In the Windows installation, it will say navigate to this download location. Go to that location and it will show you way to provide your email address and submit. If you want, you can do it. It will basically give you details about the updates. But if you don't wish to, just skip the registration and go forward like I did. You can either install Anaconda or you can install Miniconda. I would want to install Miniconda. Like as I said, for Mac and Linux, you might have to go through the steps here. But for Windows, I am just explaining you the steps. Click on this, it will download. I have already downloaded. So once you download, you will get it here in your screen here. And I am just going to the folder here. Now once you come here, you can directly double click on that and it will start installation. It is a very typical installation. You don't have to worry too much about many steps. Just a typical installation. Click on next. I agree. Just me. Click next. And click next. In this, there are four check boxes. First one is by default checked. Second one, do not check that. Not recommended. Third and fourth, you check it. Install. It will usually take 2 to 3 minutes depending upon your RAM size and your PC. Now I have a 4 GB RAM quad core, I think. It usually takes around 1 to 2 minutes. What it is doing in the background, it is installing Python, the latest version of Python and the latest stable version of Python. We'll always say, let's not say latest stable version of Python and whatever dependencies. In between, a command prompt will open like this. Don't close it, it will automatically close. Okay. Allow it to do its job, right? So let us wait for it to complete the installation. It's almost done. Yes, it is done. Click next. These checkboxes, you can uncheck them. So once you have unchecked them, you are ready. The Python is installed. Python and Miniconda packages are installed. How do you open? So you will have to open and verify. You will have to open and verify. So how do you open and verify? All you have to do is just go to your start window, right, this start button, and type Miniconda. If Miniconda is not coming, type Anaconda. Now you will see this Anaconda prompt here. Okay? You can see this Anaconda prompt here. Just click on it. Just click on it. Open Anaconda. Now on your screen, whatever you are seeing, this base is the base environment. You can create your own environment. You can create your own environment, but this is what we call it as a base environment. Okay. Now I want to know if the Python installation is successful. What I do is Python --version. Remember the command Python --version. It is done. So it is clearly saying that the Python version is installed and it is also showing you the version. Now here what you can actually do is you can create your own environment. I was explaining you, that is, in this you can create your own actual versions. That is, now this is now here not versions, environments, virtual environments. Now as I said, this is the base virtual environment. This is the base virtual environment. Now I can create one more virtual environment. So conda create -n, okay, and I am going to say, let's say I call it with a name my env, some name I create, enter. Then it will ask you for a yes or no prompt. You say yes. So it will show up everything. And then you can say, now if you in your screen, you can see that it is basically set to base, basically set to the base environment. Now I want to change it to my environment. So what I am going to do is here, CLS control, clear the screen. Okay. So here I am going to say Conda activate my env. Now you can see the base has changed. Now when I go and say Python hyphen version, now you are seeing an error. What is the error it's saying? Python is not recognized as a internal or external operable program. Okay. Why? Because now if I say deactivate, okay, Conda deactivate, it goes to the base. Okay, in this if I type Python version, it is showing the Python version. But when I am going into my other environment, now it has a problem. So you have to resolve this. How do we resolve this is basically go to your computer and type settings. In the settings, there is something called as app. Go to the app and you go to advanced app settings. App, advanced app settings. So here you will see something called as app execution aliases. App execution aliases. Go there and here you will see these two. Python.exe and Python3.exe. Two things will be shown. It is already off. Okay. But if it is on, switch them off. If it is on, switch them off. By default, it was off. But if it was on, switch them off. Okay. If it is on, switch them off. It has to be off. Okay. Close it. Then come to this and then say Python equal to 3.13.2. The name is already there, so we will give 1. So if you see that there was an error that we got here and it failed because there was a small syntax error. So let me give this here now. So Conda, I ran it on Conda activate, which is wrong. So Conda create my environment 1 and then say you have to give the Python version. The Python version is 3.13.2, right? Now let it do that. Okay. Same, it will ask you for a confirmation. You say Y. It will take some time. Let it run that. So the previous version time we just said create Conda environment. That is why it did not run. But now what we did is we created with a version number also. Now let us activate the Conda and see what happens. Now we are activating this one. And now when we run Python version, it works. So this is the setup for creating Python environment and a virtual environment using Miniconda. In the next video, we will see at how to run executions from the local. So this how do we install Miniconda in Python local? And we also saw how to create a virtual environment activate. So when we created the virtual environment, there was an error when we tried to find version. That means Python is not properly configured. Then what we did was gave the command slightly in a different way. So we gave the command like Conda create -n env1. Then we gave that. So now you create the virtual environment, and then to activate it, we'll say Conda activate virtual. Like this, you can create many virtual environments. And suppose you create a virtual environment my env1 to install 10 packages. And then you create one more environment where you create certain other packages. They will not conflict. Right? That is the purpose of creating a virtual environment. So what we have seen is we have seen how to create, how to install Python, how to install Anaconda with and we have also seen how to configure our. We have done. Now what we will do is we will see how to execute programs. So look at how to execute these programs. Now in this case, what we are going to do is, let's say I want to write a very simple program. I want to add to this PSP the increase. So you are seeing program, right? What I did was I'm using a simple notepad. You can use VS Code or anything, whatever you want to use. Now what I have done is I have done first I defined a program which takes two numbers A and B, two numbers, and then it will return the sum of it. Then I'm passing some values 10 and 2. And then I'm calling the function. Result is equal to add number. Because I have a return B. So what it will do is it will return A plus B. I'm printing it. Now I want to run this program. I want to run this. Okay. So what I will do is we do that. I'll save this first. First, I have a program folders. Then here I will take add to the extension will be .py. The location, you should remember the location where you are staying. Add two numbers, but save it. You have saved. You have written a Python program and you have saved it. Now what you will do is you will have to run this code. How do you run this code? Basically, go to your command. Go to the folder where your code is. My code is there in E drive. In E drive, there is a program called AI Chemistry. In this folder, inside that programs folder. Now I have to run. I say Python add two numbers .py to give that. So it has added those two numbers and displaying sum is. Now in this case, what is happening is I have given the numbers in the code, right? But what I want to do is I want to give the numbers while I'm executing. I want to give the numbers while I'm executing. So what you are seeing in programming, what we call the static binding. That means when the program is compiling itself, we gave the numbers or the inputs. So if you are giving the inputs while your program is running itself, that is called as static binding. So when you do a static binding, basically the numbers, the input is already given. So what I want is, I want to create a program where I want to give the numbers at runtime while the program is running. So let us see what to do. Go to the next. Here you can see that I have number 1 is equal to, I'm getting the inputs from the user. Number 1 equal to input. I've used a keyword called input. Enter the first number. Then number 2, enter the second number. So what I am doing, I am taking the input. I am asking the user to enter the number. I will store it in number 1. Then I am going to store it in number 2. Here is again typecasting. I am converting from integers to float. Converting. Are you asking, if you ask, is it necessary? No. I'm just showing you an example of how to convert from integers to float. So I've done it here. Then we are simply adding, we are not defining any function. We're just adding two numbers and then I'm printing it. So let us see how do we run this code. Save the file, save as, going to say, done, add two numbers, input. Right? Now let us run this code. See what happens. Here, coming back to this one, I'm saying Python add. So I'm saying this case now. Okay. Now see what happens. Enter the first number. Enter the second number 90. Sum is 1. So what is happening here? Here I am not just running an existing code. I am running a code and I am also passing an input. Running the code and I am also passing an input. This is the example where you run the code, you also pass it. Now, this is another way. Third way is, see, here I am running numbers. Why should I actually give one by one? I want to, in the program name itself, I want to give the input. Means we are going to create a program with runtime arguments. Runtime arguments mean while calling the program itself, I will give the input. I will not separately give. Meaning here I am importing something called system. This is a system package. It's a default package of you don't have to install. Okay. And I am going to take C. I will run the program like this. Python add.py. I will give the first number and second number. Add both of them. So how do I get that? I will say this dot argv1 means get the first argument and pass it on to the number 1. Get the second argument and pass it on to the number 2. What I have done is I am not taking input one by one. While running the code itself, while calling the program itself, I want to pass the input. While calling the number itself, I want to pass the argument called runtime argument. So if you either pass more arguments or less arguments, it will throw an error. Let's see that. Okay. So saving it. Adding with argument. Okay. Adding the numbers with argument. Now I go to the code. Then I say Python add with arguments. With now if I simply run, it throws an error. Hey, the usage is something else. You did something else. So I'm saying add T 70 80. 3 numbers I am giving. Again it says no, it is only 2 numbers. Now I am saying 2 numbers only. So it adds both of them. So you can pass the input to the program directly. It is called static byte. Or you can give the inputs when the program is running. It's called dynamic byte. We saw in this example, or you saw in this example, it's an example of that. This is also dynamic binding, but the point is that basically we don't call that like that. Say running a program with argument. Okay, running a program with argument. Now, this basically gives you a lot of options. Now, here I can also say this now. Why should I simply give 2 numbers? I can also say what operation it should do. To do addition, division, all these things also I can do that. Now, to another program. Here I am saying I am giving 3 operations. I am asking you to give the number, 2 numbers and the operation. So I can say add, subtraction, multiply, division, all these things I can give. That means I am giving the number as well as the operation. So over here I can say Python add, sorry, is a file name. File name is arg. Save this as arguments with operation. I'm giving both arguments and operation. Now, say arguments with operation. And I say 70. So the operation is missing. What are the operations? The operations are add, sub, multiplication, and division. Now, what I am going to do? I'm going to say add. It adds them. Same thing if I give multiplies them. A divides. So, so basically what we have done is we have created a uh, local installation of, and the local installation of Python, we have seen how to write a program, save it with .py extension, execute it. We executed with constant values, we executed with inputs from the user at runtime, and we also executed the arguments. We also executed with arguments and operations. All of them. Okay. So what we just saw is a very dynamic, a very, what do you say, a generic way of. Now you can also look at this from a more chemistry perspective. For example, let's say I want to write these programs. I want to write programs. Some of See, I want to find out the molarity calculus. So in chemistry, you have the concept of molarity is the measure of concentration representing the number of moles of solute per liter solution. The formula is number of moles per volume in liters. Now I want to write a Python code for that. Okay. So what we did was in AI chemistry wrote a program polarity. So we are taking two values as input. Enter the number of moles per solute, and we are asking the volume in liters. So if you give both of them, we will give you the output. Basically, what we are doing is we are taking these two values as input and we are just dividing. Not a great program, just trying to show how we apply it to anything. And you are also seeing that here you can see that. So point 2f, point 2f, we have to understand the floating point. There should be two digits after that. This I am rounding it off to two digits and followed by this symbol moles per liter. Okay. So there will be so many things that we will be showing you. You have to grasp, and sometimes we might even miss telling it. You'll have to go to Google or type or whatever and try to understand what this means. So here I'm saying, okay, I'm clarity here, and I'm saying colon dot 2f means two floating points. Floating point means after two decimals. Okay, let us go ahead and do that here. Let us run this program here, saying Python, um, right? I say run. So it's saying enter the number of moles, say 50, and the number of liters 3. You get only two digits. Can you see that? Now, if I go to my program and change this to 4 and run it again, 700. Now I get 4 digits. Now I get 4 digits. You will have to understand the concept as we go on. Only when you do a lot of exercises, you will be able to understand. Okay. Again, here is one more example. pH value calculation. Okay. pH is a measure of hydrogen ion concentration. It indicates how acidic or basic the solution. The formula is negative logarithm 10 of number of hydrogen ion concentration. So for this, we'll have a separate function. So lot of mathematical operations can be done in Python. So open that. Here you can see negative math. Math is the package. The package has been imported. So there will be a lot of packages that we'll be using. Math is a inbuilt Python package. You don't have to install separately. Okay. But if it is pandas or matplotlib, or NumPy, then you will have to install. For this case, there is no need of inspection. By default with Python, it will come, right? So here we are asking enter the hydrogen ion concentration. So the moment you give it, the response. So let us run it. It is asking, and it says 8. Then it says pH of the solution is maybe I gave a very small value. So it is minus. So, or maybe I can, sorry, let's say, I say now, indeed. So what is happening here is the moment you give the input, it's automatically calculating based on the formula, and it is giving us the output. Okay, that was another example. Then we have molecular weight of water. I want to calculate the molecular weight. So it is 2 into hydrogen weight plus oxygen because H2O, right? So again, I will write program. So just show the program molecular weight. So this is the hydrogen weight, this is oxygen weight. Now I'm giving a formula 2 into hydrogen plus hydrogen weight plus oxygen weight. So Python right, giving here there are no inputs I'm taking. Again, another concept ideal gas law calculator. I want to find out the ideal gas. So the formula is nRT by V. Then here I have the the chemistry concept is the ideal gas law relates pressure, volume, and temperature of moles of a gas. So we have the formula here, and we have created the program. So we will take the number of moles, the temperature, and the volume. On that we will calculate ideal. So come again, listen. Ideal gas.py, the enter temperature, Kelvin, 400, volume, 5. So you can start applying your chemistry concepts. Yes, for all of them, for all mathematical operations, you will have a required. All you have to do is to start applying it. Start. So basically, what we have done is we have seen how do we use, how do we install Python locally, and how do we basically uh, run the program. This comes to the end of the topic on installing, running Python